Climate change creates continuing problems for everyone. It causes natural disasters, disrupts populations, and increases mortality rates. From the EPA, we know that 78% of greenhouse gases are caused by electricity production. Our solution uses OLEDs to make electrical technologies more efficient and decrease greenhouse gas emissions. We interviewed with CEO of OLED, Elijah Zeisman-Coleman, and Scott Birnbaum, CEO of BOE Technologies, to get more information about the industrialization of OLED technology and its cost. From this, we learned that an OLED's price will decrease based on manufacturing efficiency, and will likely be applied to the automotive and aeronautical sectors. We also presented on GMS TV, our school's announcement systems, which you can find on YouTube, live in front of one of our robotics classes at Graham, and at the South Bay Peninsula Scrimmage. OLEDs, or organic light-emitting diodes, are ultra-thin display panels used in lighting and devices. They have an average thickness of 300 nanometers, which is 200 nanometers smaller than a human hair. These devices are special because they produce light by themselves and use organic carbon polymers in their emissive and conductive layers. OLEDs work using solid-state physics. Electrons travel from the device's anode, while holes, or the lack of an electron, travel from the cathode, both going towards the emissive layer. In the emissive layer, when electrons and holes mix, the electrons go into their high-energy state. As the electrons travel back to their low-energy state, a photon is released. This process all happens at a nanoscale. When compared to other common screens, such as the LED and LCD liquid crystal display, we can see that the OLED has 3 layers compared to the 5 and 8 layers in the other screens. This thickness is because of the OLED film inside the display, which produces lights that are significantly better at a fraction of the size. The main benefit of OLEDs is that they are super environmentally friendly, resulting from their ability to go completely dark and their low wattage. However, another benefit of OLEDs is that they do not produce blue light, but rather a light similar to daylight. This eliminates the health risks such as skin and eye damage caused by blue light. OLED technology also has a much wider range of vivid colors for us to view. The biggest problem we see in OLEDs is their fragility. Their organic material is greatly affected by oxidation and moisture, which limits their applications and lets them degrade much faster than LEDs and LCDs. Our solution, called SCROLED, solves these problems. We used a protective plastic at the nanoscale to surround the OLED panel, making it more durable and preventing moisture and oxygen from affecting the organic layers. To account for the degradation in OLEDs, we attached rechargeable batteries to the OLED panel. The electrons from the battery will keep the OLED running for much longer. Since the energy efficiency is also high, the batteries will last nearly 3 times the amount of time they normally would. The cost of our product when used as a phone has a price of $230.10. SCROLED is $469.90 cheaper compared to other OLED phones and screens, or on average, 47% cheaper than comparable displays. This technology also uses less than 50% of the power LEDs and LCDs run with. For our model, we applied glow-in-the-dark vinyl to an ultra-thin plastic sheet, then rolled it up into a plastic tube to demonstrate the scrolling aspect. We tested this by placing it in a dark room and watching it glow as a screen would. Now let's watch it in action. SCROLED technology keeps all of the OLED's original properties, including the reduction of greenhouse gas emissions. Our innovation is super portable and compact, rolling in and out of a small frame. With our innovation, our technology can be applied in all device and lighting sectors. We learned a lot when researching and developing our ideas. It is safe to say that our innovation will have a significant impact on the world.